Hi everyone, a very warm welcome to all of you who are available live on the channel now. Give me a quick update if you guys are able to hear me well. Sumit, Shreya, Akshat, all of you who are live on the channel now. Give me a quick update if you guys are able to hear me well. If you guys are able to uh, see the content which is being live. And it's going to be a fun session that we have kept for all of you. It's going to be more inclined towards the section of your geometry paper of your CAT examination. We'll see some of the previous year questions which has come repeatedly over the years in the CAT and the other management exam, and possibly I'm going to give you all the possible good tips and techniques in which you'll be able to solve the question live, fast, and quicker. Cool. Give me a quick update if you guys are all set to solve the questions along. And on this note, we'll quickly start with the session. Now, understand one thing: the proportion of geometry questions, I mean, the proportion of geometry questions has gone low since the year of 2018-19 onwards. But this time, even if you know that there are 26 questions which is going to come up in the paper of your CAT exam, around about 2 to 3 questions will purely is going to come from geometry only. And the majority of the questions which you will see from the sections is going to come from topics like triangles, circles, and polygons. Okay, so make sure the important properties, theorems, and formulas you are able to understand the pure concept and then use the applicative mind to solve the questions really faster. So, usually, what happens is you possibly will divide the entire math into various modules. You've got arithmetic, algebra, geometry, and modern math, right? And we learn everything distinctly. But howsoever, there are certain applications of arithmetic which can be used in algebra. There are certain applications of arithmetic and algebra together which can be used in geometry to solve the same questions. So you got to link everything which looks dissimilar. You got to use the important properties of arithmetic and algebra too, which is going to help you out to solve the geometry questions too. And that's what the objective for today's session is also going to be. Cool. So using the basic properties of arithmetic and algebra, I'm going to solve the questions which has come in geometry. As said, predominantly you will see questions which are based on triangles, circles, and polygons. And if you ask me the sub varieties of question which will ever come in the examination, there are three important sub varieties. One, you will see questions which are based on finding the length of the given segment. Second, you will see questions which are based on finding the area of the given figure. And third, you will see questions which are asked about finding the volume of the given figure. Clear? So length, area, and volume are the three kinds of question which may get featured either in triangles, circles, or polygons. We understand length, or let's say radius, diameter, height, which basically will be given in the units of meter, centimeter, would be basically a one-dimensional units. Area, on the other hand, will be a two-dimensional unit, and volume, on the other hand, would be a three-dimensional unit. Okay, we got to link and delink all the possible combinations between the one-dimensional unit, two-dimensional unit, and the three-dimensional units to possibly crack all the questions which are linked with the relation between changing the length to changing the area, changing the area related to changing in the volume. And there are dozens of questions which will come up. I repeat, there are dozens of questions which will ever come up in the given examination like this. Cool. On this note, let's quickly begin with the session. Some small regular updates. Please do regularly follow us on all the social channels, especially Instagram as well as on YouTube. And every Sunday live webinar, make sure you are regularly attending, which happens at 12 p.m. Cool. Now, there are a couple of sure short CAT patterns which usually comes up in the examination. I repeat, there are a couple of sure short CAT patterns. I'm saying pattern, it means the pattern based questions. Okay. And these questions are of the following type. One is the change in ratio to change in percentage. One is the change in ratio to change in percentage. Second is going to be length based question where you possibly have to symmetrically cut the diagrams and find out the length. Third, you will see questions which are based on heights and distances, where you will see ladder based questions, or let's say lamppost or ship based questions which will ever come, right? And these are the most standard questions. If you look at the paper of 2015 and 2009, where both the year papers were set up by IIM Ahmedabad, you have seen one heights and distance questions regularly getting featured. So this time also there are high chances that you will see at least one question getting featured on heights and distances, which are basically the properties of right angle triangle. So make sure you regularly follow the important questions which are coming from this domain. Okay. Next, basically, are questions which are called as 4 by 1. Basically, these are the questions which are polygon inside a polygon, like let's say a square inside a square or rectangle inside a square, likewise. Okay. And then you'll also see questions which are circles inside the polygon or polygon inside the circle. Okay, these are two important questions which will ever come up in the examination, which will be all about finding the area of the maximum circle which can be inscribed in a square, finding the diagonal of the biggest square that can be inscribed in a circle, and likewise so on and so forth. Clear? And towards the end, you'll also see some of the questions which are based on GP. So some of the geometrical figures will pretend that they are following that geometric progression, and you will see questions which are based on them also. In today's session, possibly, let me give you a clear perspective about some of the questions which are inclined towards ratio to percentage change, length-based questions, and heights and distances. The 4 pi 1 and geometric progression I'll be taking up in the upcoming webinars for all of you. Cool. Cool. Let's see the first question. The first question is basically the change in ratio to percentage. The change in ratio to change in percentage. We understood that the given units of length, or let's say radius, or diameter, or breadth, all these are the classic examples of one dimensional unit. Two dimensional unit will discuss something about area, and three dimensional unit will discuss something about volume. Let's understand how does a one-dimensional unit changes the two-dimensional unit, and how does a two-dimensional unit changes the three-dimensional units. Clear? It says if 1D units, I repeat, if 1D units are in the ratio of A is to B, I repeat, it says if one-dimensional units are in the ratio of A is to B, then the corresponding two-dimensional units will be in the ratio of A square is to B square, and the three-dimensional units will be in the ratio of A cube versus B cube. Something like, let's say there are two squares. Okay, the ratio of length of the first square versus the second square is 1 and 2. The ratio of length of the first square versus the second square is 1 is to 2. And the question is about find the ratio of the area. We know area is nothing but side square. I repeat, area is nothing but side square. So it's going to be 1 square versus 2 square, which is basically 1 is to 4, which basically can also be translated in the form of a is to b, which is one dimensional unit, could become a square and b square in a two dimensional unit. Clear? Using this simple property, let's see if you're able to solve the actual CAT question which came in the year 2017. The question which you're able to see on the screen is the actual CAT 2017 question. Cool. Let's see if you're all set to solve this question along. It says there are two solid spheres. I repeat, let A and B are two solid spheres such that the surface area of A is 300 percentage higher than the surface area of A. Clear? The volume of A is found to be K percentage lower than the volume of B. I repeat, the volume of A is found to be K percentage lower than the volume of B, and the question is find the value of K. The question is what? The question is find the volume of K. Clear? So what they are discussing about, they have given you the ratio of surface area. The ratio of surface area, which basically a two-dimensional unit, is in the ratio of, let's consider A and B. If I say the area of A is 1, the area of A is 1, the area of B would be 300 percentage more than that of A. 300 percentage more will make the value of B to be as 4. So it says the area of the two spheres, let's say A and B, is in the ratio of 1 is to 4. Is in the ratio of 1 is to 4. And the question is find the ratio of volume. The question is find the ratio of volume. Now, directly you cannot figure out the relation between area and volume. We need everything to start from the base of one dimensional unit. If 1D is in the ratio of A is to B, 2D will be in the ratio of A square and B square, and 3D will be in the ratio of A cube and B cube. Likewise, if the surface area is given to you in the ratio of 1 is to 4, but obvious the one dimensional unit, let's assume the radius, okay, or the height, could be in the ratio of 1 is to 2. Because if it was in the ratio of 1 is to 2, only then the ratio of area would be 1 is to 4. Now you already have found out the ratio of one dimensional unit in the ratio of 1 is to 2. So 1D is 1 is to 2, 2D would be 1 is to 4, and 3D, which is basically the volume, would be in the ratio of 1 cube versus 2 cube, which is 8. So it's like the volume of sphere A, let- let's assume it to be 1x. The volume of sphere B would assume it to be as 8x. The question is 1 is how much less than 8? The question is 1 is how much less than 8 is the only question in terms of percentage, because it says the volume of A is found to be k percentage lower than the volume of B. So the question is only about 1 is how much less than 8. 1 is 7 less than 8, and the answer would have been 7 by 8. Would have been 7 by 8, which is nothing but 1 minus 1 by 8. 1 upon 1 is 100. 1 upon 8 is 12.5. If you subtract both of them, the value will become 87.5 percentage. Possibly for explanation, I have taken more time, but the value of this question can be answered like in like 10-15 seconds. The surface area is 1 is to 4. So the one dimensional unit will be 1 is to 2, and three dimensional volume would be 1 is to 8. And the question is 1 is how much less than 8? It's 7 upon 8. 7 upon 8 is 87.5 percentage. Just three steps and the answer could have been out. I hope this is clear to all of you who are live. Yes or no? These are a couple of good questions that you can expect in the paper to come up. Using the same application, what you have learned as of now, let's solve one more question. Okay, this question which you're able to see on the screen is an actual character 2016 question. And I'm sure with the usage of the same example and the application, you'll be able to solve this difficult question too. And all the questions which you'll be regularly practicing on the live webinars, you will be able to see all the actual correct previous year questions itself. It says a right circular cone, I repeat, a right circular cone of height h is cut by a plane parallel to the base. So let's assume this is a cone what has been given to you, and the height of this cone is h. And it says it has been cut by a plane parallel to the base at the distance h by 3 from the base. So let's assume this is the plane which is cutting the cone into two halves, not equal, by one third. So let's assume this value is h by 3 and this is going to be 2h by 3, the upper part. So basically, you've got a small frustum and you've got a cone. I repeat, you will get a frustum and you will get a cone if you cut the cone into some halves. The question is then the volume of the resulting cone. Let's say this is the cone, small cone, and the frustum. The volume of the resulting cone and the frustum is going to be in what ratio? Okay, let's see if you're able to solve the question with the most simplistic approaches. Now, if you cut a cone, basically you will find a smaller cone. You will find a smaller cone like this. And there was the original cone which had a height of h. There was an original cone which had a height of h, which has been cut into some half. And this time, the smaller cone will have a height of 2h by 3, right? 2h by 3. And the bigger cone has a height of h. So if I assume, let's assume the bigger cone has a height of 3. Let's assume the original cone has a height of 3. Then the smaller cone, which is this half, will have a height of just 2. With a height of just 2. If I compare the height, if I compare the height of a smaller cone versus the original cone, then you will see the height will be in the ratio of 2 by 3. You will say the height will be in the ratio of 2 by 3, right? We know height is nothing but one dimensional. So in that case, the volume of the two cones, the volume of the smaller cone versus the bigger cone or the original cone would be how much? Would have been 2 cube versus 3 cube, which basically is 8 is to 27, which basically is 8 is to 27. So now you will say this part of the figure is originally carrying 8 of the given space. This part of the figure, in terms of volume, would be 8x. And the total cone is basically how much? Is basically 27x. So if out of 27, 8 has been occupied by the smaller cone, then the frustum would be how much? The frustum would be 27 minus 8, which is going to be 19. So, I mean, straightforwardly, you've got the answer also. So the ratio of smaller cone versus the frustum would be 8 is to 19. The ratio of volume of the smaller cone versus the original cone would have been 8 is to 27. But the question is not about a bigger cone. The question is only about the ratio of smaller cone and the frustum. So you'll mark which option? You'll mark option number B, which is 8 is to 19. Is this clear to all of you who are available live on the channel? Perfect. Everyone out here? In a very simple way, if I have to re explain you this question, okay, you have a cone which is being cut by a plane parallel to the base at a height of one third. So this is one third, this is two third. Perfect. So this height would be 2 and the original height would be 3. So the height is in the ratio of 2 is to 3, which is one dimensional. So the ratio of smaller cone versus the original cone would be 2 cube 8, 8 cube 27. We know if 1D is A is to B, then the 3D units will be in the ratio of A cube versus B cube, which is 8 is to 27. So this total you will say is 27 units. The smaller cone is basically 8 units. So the leftover frustum would be 27 minus 8, which is 19. And hence the answer for the given question is as simple as 8 is to 19. Now, this is the most simplistic explanation which I can give it to you to solve the question. I hope it has been clearly understood to all of you. Right? All right. Let's take the next question. The question which you're seeing here is again a 2017 question of CAT. And solving this question, possibly you will take less than 10 seconds to crack it live. Because, I mean, it's one of the questions which are based or driven towards the applicative um, part of solving the math questions. It says a triangle PQR. I repeat, a triangle PQR is an equilateral triangle with a length of 5 unit. I repeat, a triangle PQR is an equilateral triangle with the height or let's say with the side of 5, 5 and 5 units. O is any point in the interior of the triangle PQR. Let's assume this is the point O. Let's assume this is my point O, right? Which is in the interior of the triangle PQR. The question is find the sum of the perpendicular distance. Find the sum of the perpendicular distance from O to all the three sides. From O till all the three sides. So I want the length of this plus the length of this plus the length of this. Or possibly that let's assume the triangle to be as A, B, and C. Clear? I want the height or the distance of OA plus OB plus OC. This is the overall length which I would want to solve the question. This is the overall length which I would want in the given question. So this is my point O. OA, OB, and OC. See, the length of OA or OB or OC will be dependent on the position of this point O. I repeat, the length of OA or OB or OC will be dependent on the position value of point O. If let's say point O is here, then possibly OA will be more, O will be shorter, OB is shorter, and OC is also shorter, right? But towards the end, if you just visualize, if you try to understand what I'm trying to tell you here is the total length, I repeat, the total length of OA, OB, and OC will be all same, irrespective of the position value or irrespective of the position of point O. I repeat, irrespective of the position of point O, the total length of OA plus OB plus OC is going to remain the same. So it's like you have got three threads. So let's say you tie some knots in a given thread. I repeat, you are tying some knots in a given thread and making it stretchable on three sides. Making it stretchable on three sides, but that length is going to remain uniform. The length is going to remain uniform. If I stretch on the one side, possibly the second length is going to become smaller, and possibly either way around. If I stretch it on the other side, the former length is going to become smaller. So this length of OA or OB or OC is basically a length of the single thread. Let's assume this is my single thread, which has been stretched to connect to A, to connect to B, and to connect to C. To connect to A, to connect to B, and to connect to C. This is one single thread. All what I'm saying is the lower I presume the position of O, the lower I presume the position of O, the shorter will be the distance of OB and OC. Assume, let's say this is the point O, which is lying on BC. I repeat, the position of O, the position of O is lying on BC. If the position of O is lying on BC, then OB and OC will become negligible because the whole length of that side has now been occupied by, let's say, AO. And in this case, all what you can see here is here OA would correspond to the height of the given triangle. OA would correspond to simply what? OA is going to correspond to what? The height of the given triangle. The further the value of O goes up, the position of O goes up, the smaller the length of OB and OC will start emerging. But I want that to happen. I don't want that to happen because the same answer can be found out by finding the length of AO. That's it. With the simple assumption that O is on the line of BC. O is on the line of BC. In that case, it is just about defining the height of the given triangle. It's an equilateral triangle. So the height of an equilateral triangle will be given by what? The height of the equilateral triangle will be given by root 3 by 2 into the side. Would be given by root 3 by 2 into the side. What is the side which is being given to you of this triangle? It is being given to you as 5. So the answer for this smart question would have been root 3 by 2 into 5, which is 5 root 3 by 2. And smartly will mark option number C to be the final answer. Sumit, Madhur, Sanjeev, all of you have given the right answer. If you have understood this concept, please hit the like button. I'll get the notification, or you can put that into the comment box. I'll go through it. If you want me to re-explain this, I mean, this is one of the easiest questions which can come up in the given exam. Okay. As said, you will also see questions. As said, you will also see questions which are based on heights and distances. Okay. Now, heights and distances, you will always see your same template-based questions getting featured every year, right? Either it could be a ship-based question or a lamppost-based question, or you will see a ladder-based question. So this is a high. Uh, there would be a very high chance that in the year 2021 also you can expect one question which is going to get featured on heights and distances. Clear? Using this, possibly you'll see all the great questions can be solved with a similar approach. All what I'm saying is all the time, whenever you see questions which are based on heights and distances, all the time, whenever you see questions which are based on heights and distances, you will see a triangle which is a right angle triangle. You'll always see a right angle triangle getting featured in all the questions that we are discussing here. Clear? And any of the right angle triangle which comes up in the paper would either be a 30-60-90 triangle or the 45-45-90 triangle. Either it's going to be a 30-60-90 triangle or it's going to be a 45-45-90 triangle, right? And all the values of the sides of this right angle triangle, I repeat, all the values of the sides of this right angle triangle, which usually they will ask you in the question, are basically the combinations of Pythagoras triplet. Are the combinations of Pythagoras triplet. These triplet values, I'm sure you will have done it in the basic classes also. For example, one of the simplest value which you would know is values like 3, 4, and 5. 3 square plus 4 square will become 5 square, which is 25. Clear? Similarly, you will see values like 5, 12, 13. You will see values like 8, 15, 17. You will see values like 9, 40, 41. You will see values like 11, 60, and 61, so on and so forth. The only part which I want you to do, I repeat, the only part which I want you to do is to try to memorize as many Pythagoras triplets as possible. I repeat, try to memorize all the as many Pythagoras triplets as possible. If you have done that, you don't even need to solve these questions, which is going to be quite easy for you to solve in the paper. For example, this is a pretty old question. You will see question. This question got featured in the year 2012 and 14 too. Clear? Let's see if you're able to decode this question and solve this. It says a ladder. The question says a ladder leans against a vertical wall. A ladder leans against a vertical wall The top of the ladder is 8 meter above the ground. The top of the ladder is 8 meters above the ground when the bottom of the ladder is moved 2 meter further. When the bottom of the ladder, I repeat, when the bottom of the ladder is moved 2 meters further away from the wall, the top of the ladder rests against the foot of the wall. The top of the ladder rests against the foot of the wall. The question is find the length of the ladder. Okay. In a very simple way, they're saying this is the original position of the ladder and the wall, and the height of the top of the ladder from the base is 8 meter. What they have told you. So this length is 8. Okay, and they're saying let's assume this is the value x, and if you stretch it to be 2 meter more, if you stretch it to be 2 meter more, then the top of the ladder will rest against the foot of the wall, which means this point of the ladder is going to come and meet the bottom of the floor, at the bottom of this floor. Clear? So this is x, this part is x, this part is 2. So the total length of this part will be x plus 2, which will also be equivalent to the length of the ladder. Which will also be equivalent to the length of the ladder, right? So if you have to make this diagram more clear, you will see the value will look like x. Sorry, this is 8, this is x, and this is x plus 2. Majority of you will use Pythagoras theorem to solve this question, which is x plus 2 the whole square will become x square plus 8 square to find the value of x. But the only part which I would want is tell me the Pythagoras triplet which is starting from 8. The only question that you need to answer is there any value of the Pythagoras triplet which has 8 in the combination? Yes, there is. Clear? You have got 8, 15, and 17 as one of the important Pythagoras triplet. You've got 8, 15, 17 as one of the important triplet. Even if I solve the equation, you will get the value of x to be as 15. But I don't want to solve. The question is I don't want to solve because I know this one Pythagoras triplet which has got 8, 15, and 17 as a combination. So they're asking about the length of the ladder. Length of the ladder would be as simple as 17. So the moment I saw it to be as 8, x, and x plus 2, the answer would have been as simple as 8, 15, and 17, and straightforwardly we'll mark 17 to be the easiest answer, accurate answer here. Clear? And that's how beautifully you'll be able to solve these questions live. I mean, this is not going to be difficult provided you have the applicative mind, all the basic concepts, you know it well. Already know it well. The only part which I would want you to solve is the as many as old paper questions, and around about 15 to 17 national full length mocks. And after every mock, you need to come live for the analysis and the recommendation too. Cool. Cool. And on this note, I'll take a sign off. I'll see you in the next webinar ahead. On this upcoming Sunday, also, we'll be coming up with a mega workshop of the management exam. So make sure you follow all the important links in the description box and follow us regularly on the website and the social channels so that you guys get the regular updates of the upcoming webinars and the workshops that we are keeping for all of you. All right, then. On this note, I'll take a sign off. I'll see you in the next session. Till then, stay tuned and start learning as much as possible. Thank you. I wish you all the best for the given examination.